Hello students, welcome you to this session. Almost we have come to the end of this chapter, right? So in this class we are going to study entirely different one, graphing functions using transformations. Suppose a function is given, how to draw the graph, that first. Then if we make some change in the graph or some change in the function, what happens to the graph? Okay, that we are going to study. There is a very simple topic. For that you need some of the basic graphs. For example, y equal to x square, y equal to x square. So it looks like what is studied in 10th standard, right? It's a U graph, parabola graph. So this is the graph y equal to x square. So this is the basic thing you must know. Y equal to x square, the graph will be like this. Then suppose if you make some change, x square is the function, fx equal to x square. If it is x square plus 1 or x square minus 3, what will happen to this graph? Or instead of x square, it is x plus 2 the whole square. Or x square is given, this is the graph of x square. Then what will happen for 7x square? Or what will happen to 1 by 2x square? All these things we are going to study in this topic. Okay, if you know the basic graph, then some changes, if you add something, subtract something, multiply with something, what will happen to the graph? Okay, that we are going to study in this topic. Another one, y equal to modulus x. Modulus x means, it has two values, right? Plus x or minus x. Plus x or minus x. So y equal to plus x when x is positive, or y equal to minus x when x is what? Negative, right? So here the graph will be like this. Y equal to modulus x, okay? This is a graph of y equal to modulus x. So these things you have to remember, okay? So y equal to modulus x. Then as I said in the previous one, suppose modulus x plus 3 or modulus x plus 3. Both are different, right? So what will happen? That we'll see later, okay? Then another one, y equal to sine x. Y equal to sine x. In trigonometry we'll study that in detail. See y equal to sine x. Here we take x-axis, y-axis, and for sin x and cos x, the maximum value will be what? Plus 1. Maximum value is 1, and the minimum value is what? Minus 1. And 0, 90, 180, 270, 360, and so on. Left side, minus 90, minus pi by 2, minus 180, and so on. So when you draw the graph, sin 0 is 0. Sin 90 is 1. Sin 180 is 0. Sin 270 minus 1. So when you draw the graph will be like this. So this graph we call it as what? Sine graph. Okay. So this is sine graph. Same way it will come here also, right? It will come like this. So it goes on like this. So this function, this curve is what? Sin x. Same way cos x you can draw. But some change, because cos 0 is 1, cos 90 is 0, cos pi is minus 1. So here the curve will be like this. So this curve is what? Cosine curve, right? So here it comes like this left side. So hope you understood the basic curves. So y equal to x cube. So all this we'll study later, okay? When 11th and 12th, once you finish, everything will be thorough, okay? So y equal to x cube, this is the curve. This is y equal to x cube. Then cube root of x, y equal to cube root of x only x raised to 1 by 3. Okay, so here the curve will be like this. So these are some of the basic curves you need. So now let us see what are the transformations we have here. Graphing functions using transformations. We are going to study 3 transformations in detail. The first one is reflection. You know what is reflection? If you stand in front of the mirror, okay, you can see the reflection, right? Suppose, say, x-axis is here. Say this is x-axis and y-axis. If we have a line like this, suppose x-axis acts like a mirror. Its image you can see here, right? So it is a reflection of that line on x-axis, okay? So like that we are going to study in reflection. Still 3 things we are going to study. Reflection on x-axis, reflection on y-axis, and reflection on the line y equal to x. So the line y equal to x, this is the line, okay? So this is the line y equal to x. So reflection. Then the next one is translation. So this is another transformation. Translation means the curve shifts. The curve shifts to the right side or left side, or it moves up or moves down. So that we study when it moves right side, when it moves left side, everything we are going to study in the second transformation, translation. And the third one is dilation. In dilation, the curve either expands or shrinks. It shrinks or expands. Okay, so that we study in dilation. Okay, in the first and second, the curve preserves the congruence property. So only the position changes. So the shape and size remain same. Okay, it shifts one place to another place. Either sides or move up, or it is a image. Okay, so same shape, same size only. So the congruence property will be preserved. But in dilation, sometimes the curve shrinks. So it changes, right? Sometimes it extracts. Okay, so it expands. So there will be change in dilation. Okay, so now let us see one by one in detail. The first one is reflection. See what I said. A curve is given. F is the given curve. L is a line. It acts like mirror. So its image will be here. F dash. Okay, F dash is the reflection of F on the line L, right? F dash is the mirror image of F with respect to L. Already I said here three types of reflections we are going to study. The first one is reflection on x-axis, reflection on y-axis, and reflection on the line y equal to x. Listen. Suppose f of x is the given curve. F of x is the given curve. Reflection on x-axis, it is denoted by minus fx. Reflection on x-axis. So what's the meaning of that? Whatever you have the above, same thing should be here also. So this is reflection on x-axis. Reflection on y-axis is represented by f of minus x. So can you see the difference? The first one is minus fx. Now f of minus x. The difference is like this. Say the function is x square. Suppose the function is x square. The first one is minus of the function, minus of x square. But the second one is f of minus x. That means in the function replace x by what? Minus x. That means minus x the whole square. That's the difference. Minus fx, f of minus x. That is reflection on y-axis. And the third one, reflection on the line y equal to x. It is f inverse x. F inverse x. You studied inverse functions and all, right? So three types of reflections. Reflection on x-axis. So fx is the given function. Reflection on x-axis, y-axis, on the line y equal to x. For x-axis, minus is outside. Minus fx, right? On y-axis, minus goes inside. F of minus x. Then on the line y equal to x, the minus goes up. It is not minus actually, f inverse x. Okay, for you to remember. First minus outside, then minus inside, then minus goes up, right? Reflection on x-axis, minus fx. Reflection on y-axis, f of minus x. Reflection on the line y equal to x, f inverse x. Okay, so these are the three things you remember. So consider the graph y equal to fx. Reflection about x-axis, minus fx. Reflection about y-axis, f of minus x. And reflection in y equal to x. It is f inverse x. Look at this. Y equal to x square. Just I'm going to see some examples. Y equal to x square. This is the curve already explained, right? Y equal to x square. The curve will be like this. Y equal to minus x square. So x square is the function, right? Fx is x square. Fx is x square. Then here actually minus of fx only. Minus x square, right? So minus of x square means you are putting a minus sign outside, right? So this is reflection on x-axis, right? Reflection on x-axis because minus fx, minus is outside. So reflection on x-axis means y equal to x square is a given curve. Its image on x-axis, about x-axis. X-axis acts like a mirror. So you can see the image this one, right? So you can see below that. So that is y equal to minus x square. So hope you understood that, okay? Okay, now look at this one. So you know this one, consider this curve, y square is equal to x. Y equal to x square, you know, right? Y equal to x square, that's what we saw now. Y equal to x square. Here y square equal to x means the curve will be like this. So here we take this positive part, that is y equal, if you take y root x, right? Root x plus or minus, so this is a negative branch, you take the positive branch alone, only this part, first quadrant, y equal to root x. Suppose you take the function fx equal to root x. What is f of minus x? F of minus x means for x you put minus x, you will get root of minus x. Then f of minus x means minus is inside. If minus is outside, reflection on x-axis. Reflection on x-axis means it should come like this, right? But here, f of minus x, it is reflection on y-axis. Now y-axis is the mirror. Okay, so for this one, the reflection on about y-axis is this part. Okay, so this is reflection on y-axis. And look, another one, y equal to e raised to x. Okay, that I didn't say. This is the curve, y equal to e raised to x. You remember that also. E raised to x, and here it is given what? Log x. Listen, they are inverses. I'll explain to you how they are inverses. Already you studied how to find inverse, you know, right? Y equal to e raised to x. Y equal to e raised to x. Suppose the function they are giving fx equal to e raised to x. I want to find the inverse of this. I want f inverse x. What's the method? You take that fx as what? Y. Then from this relation, you try to find x value. How can you find x here? You take log on both sides. So log y equal to x log e. Log e is 1. Log e is 1. So you are getting x is equal to log y. You got x equals something. So this is the inverse. So what is f inverse of x? It is log y. Since f inverse x, you change this variable, right? You write log x. So fx is e raised to x. What is f inverse x? Log x. So remember, e raised to x and log x are inverses. Okay. So y equal to e raised to x is this one, and y equal to log x is this one. Okay. So here, this is the mirror image on y equal to x. So it is a reflection on the line y equal to x. Okay. So for objective, it is important. Okay. The reflection of e raised to x on the line y equal to x. What's your answer? It is log x. Okay, now listen here. So first one is reflection, and 3 types of reflection we said. They say fx is a given curve. Reflection on x-axis, minus fx. Reflection on y-axis, f of minus x. Reflection on the line y equal to x, it is f inverse x. Okay, so these are the 3 reflections you have to study. Second transformation is translation. Translation means shifting. Whether you shift to the right side or left side or above or below. So here we are going to study 4 types. So please listen here. F of x is the given curve. F of x is the given curve. F of x plus c. F of x is the given curve, right? So inside you are adding c. F of x plus c. Inside you are replacing x by x plus c. So c units, right? So you shift c units to the left side. Shift c units to the left side. If it is plus, opposite. Okay, for plus, you move to the left side. So if it is f of x plus c, x minus c, f of x minus c, c units to the right. Shift c units to the right. Now f of x, outside you are adding f of x plus some letter. C means c units, d means d units. Now this is for above and below. If you add inside, it is right side or left side. If you add a positive number, move to the left side. If you add a negative number, move to the right side. Opposite, moving right and left. Opposite side, you remember. Negative means move to the right side. Positive means move to the left side. But when you add outside f of x plus, f of x is the function. With the function, you are adding some number. So that is for above and below. The same direction. Plus means above, minus means below. That's all. If you add plus 3 units above, the curve moves 3 units above. If you add minus 2, that is we are subtracting 2, right? F of x minus 2 units below. Okay, it shifts 3 units below. Okay, so these are the 4 things you remember. If you add inside, when you add inside, adding or subtracting, so the direction is right or left. So just opposite here. For plus, move left side. For minus, move right side. If you add outside f of x plus d or f of x minus d, f of x is the function, Outside there is a plus d or minus d, that is for above and below. So here same direction, plus, above, minus, below. So you can remember very easily. Okay. So these are the transformations under what? Translation. So two things we studied. First one is reflection. Second one is what? Translation. Here there are 4 types of shifts we studied. So look at this some example you see. F of x equal to modulus x. You know what is modulus x? Already explained. So this is modulus x. Okay. Modulus x. Next one is modulus x minus 1 inside. Inside means moving right or left in the different directions. Okay. Here inside only, but minus 1. Minus 1 means move 1 unit to the right. Move 1 unit to the right. So in the right side, this is 0. Say this is 1. The curve moves 1 unit to the right. Hope you understood. But the next one is, see the third one, f of x equal to modulus x plus 1. Inside only. Inside only, so moving right or left, but plus 1. So move 1 unit to the left side. Move 1 unit to the left side. So it will be minus 1 here. So 1 unit to the left side. So the curve will be like this, right? Hope you understood this. But same thing, modulus x plus 2 means what? First you draw modulus x, right? Say this is modulus x. So plus outside plus 2 or minus 2, above or below. If it is plus, 2 units above. So 2 units above. So this is 0, this is 1, this is 2. 2 units above. So the curve will be like this, right? If it is x, modulus x minus 1, 1 unit below, right? 1 unit below. So I say here it is minus 1. The curve will be like this. Okay, hope you understood this. So same thing here I given. F of x equal modulus x. Yes, this one, the blue one, that is f of x equal modulus x. Modulus x minus 1, 1 unit below. So it will come here. Okay, modulus x minus 1. And the next one is modulus x plus 1, 1 unit above. Okay, so 1 unit above. Instead of 0, it starts from what? 0. Sorry, 1. Okay. So 2 transformations we studied. Reflection. Reflection 3 types. Reflection about x-axis, reflection about y-axis, reflection on the line y equal to x. For x-axis, minus fx. For y-axis, f of minus x. And the third one on y equal to x, f inverse x. Okay, so that is reflection. And the second one we studied translation. So first one is shifting right, left. For that, we add or subtract inside f of x plus c or x minus c. F of x plus c. X plus c means c units to the left plus c. So c units to the left. F of x minus c. C units to the right. And the another one, f of x plus c or f of x minus c. Outside fx you add. So this is for above and below. Same direction. Plus means above. Minus means below. Okay, so these are the first two very important transformations. In these 2 transformations, one thing special I said, so the curve preserves its congruency. Okay, there is no change in shape. So modulus x, the same thing, it moves up or down or moves down, right or left, right? So it preserves the congruence property. But the next one, the third one is dilation. So here, the curve shrinks, it moves towards y-axis or stretches moving towards x-axis. Let us see when. Okay. So dilation, just to explain to you later, you can read this. Say f of x is the function. F of x is the function given. And that fx you multiply by some number. Say f of x is the function. Okay. Say this is fx equal to modulus x. I multiply by a number. So far we added, right? Adding, subtracting, changing the sign and all. But now I'm finding k of x, fx. K into fx. So here, the curve just sometimes it expands or shrinks, right? When? Depends on this k value. If this k value is more than 1, if k value is more than 1, it moves away from x-axis. It moves away from x-axis. So now this is x-axis, right? So moves away from x-axis means it moves towards y-axis, right? It moves towards y-axis. That means it moves like this, moving away. Suppose you multiply by a very big number, then still it moves very closer to what? Y-axis, moving away from x-axis. If you multiply by a number which is less than 1, 0 to 1, Suppose you are multiplying by, say, 0.25 fx. Then it moves closer to x-axis. Move closer to x-axis. Now the curve will be like this. Suppose you multiply very small number 0.25 fx. It will be a little more closer, right? So it will be very close to x-axis. Moving towards x-axis, or you can say moving away from y-axis. So how to remember easily? I'll tell you some easy method for this. Please listen. See, fx is the curve. So I'm taking f of x equal to x square, some other familiar curve, right? So y equal to x square. You know what is this curve? Y equal to x square is this curve, right? This is y equal to x square. Now I want to find, say, 7x square. So you are multiplying, so it comes under dilation. If you add 7, if you add x square plus 7, it comes under translation, right? 7 units above the same curve, you move 7 units above, the curve will be like this. Okay, hope you understood that. But here we are multiplying by 7, right? Multiplying by 7 means it comes under dilation. Either it shrinks or expands. So I said, so you see this k. What is k value here? 7, more than 1. So more than 1 means moves towards y-axis. Or you remember like this. This gap you see. So this is x-axis, right? This gap you see. When you multiply by a number more than 1, so that is when you multiply by a bigger number, this gap will increase. This gap will increase means the curve will be moving away from x-axis, it moving towards y-axis, right? So the curve will be like this. But same thing if you multiply by a very small number. Suppose I multiply by half x square. So this is less than 1, right? So less than 1, small number. So the gap will reduce, gap will be reduced. That means it is moving towards x-axis. Okay, so the gap will be reduced. Earlier it was like this, right? Now the gap is reduced. So like that you remember. When you multiply by a bigger number, that means more than 1, the gap will increase. Gap will increase means moving away from x-axis or moving towards y-axis. When you multiply by a smaller number, meaning less than 1, 0 to 1, then the gap will be less, gap will be reduced. That is the curve is moving towards x-axis, stretches, right? Moving away from y-axis. Okay, hope you understood. So this is what you have to remember. Look at this one example here. Same example only. I think you can go through that very easily. So then sine curve, that's something important. Suppose I want to find this one, y equal to 2 sine x minus 1 plus 5. It's a 5-mark question. So you cannot draw the graph of this directly. You have to start from the basic things. You start from basic. One of the familiar curve you take. Sine is there, so you start with sine x. You start with sine x. You know sine curve will be something like this, right? So this is sine curve. Then what we need next, first sine x. Then sine x minus 1. Sine x minus 1. You are subtracting 1 inside. It is not sine x minus 1. So here translation, right? Shifting only. But sine x minus 1 inside, subtracting 1. Subtracting 1 means move to the right side. 1 unit to the right side. Okay. So this point will come here. 1 unit here. So the curve will be something like this. So the curve will be like this. Okay. So earlier the curve is this one. Now 1 unit it moves, right? 1 unit it moves. So the curve will be like this. Second one. So this is sine x minus 1. Now you have to multiply by what? Like the stage by stage you have to do. So first sine x, then sine x minus 1. Now multiply by 2. When you multiply by 2, it comes under dilation, right? When you multiply by number. See the number 2, more than 1. So moving towards y-axis. Okay, so moving towards y-axis. So now the curve moves like this. Okay, earlier it was like this. Now multiply by 2, the gap will increase, right? That means the curve is moving towards y-axis. So this is 2 sine x minus 1, this green one. Okay, 2 sine x minus 1. But what we need? 2 sine x minus 1 plus 3. The function we know. Now plus 3. Outside you are adding 3. So 3 units above. The same thing, it moves 3 units above. Okay. So this is the first curve, 2 sine x minus 1. Now plus 3. So the same curve moves 3 units. See, here it is minus 2. So minus 2 means here 2 units, here 1 units. Okay, 3 units it moves. Okay, 3 units above. If it is minus 3, 3 units below. Okay, this is what happening here. So with this idea, we'll try to work out some of the example sums. Okay, please listen here. For the curve y equal to x cube. Okay, this for in the question they given this curve, but you study. Okay, y equal to x cube. Already I given the basic curves, 4 curves I given. That you studied, so you can answer any question. Okay, so y equal to x cube is this curve. Now first part is y equal to minus x cube. So minus is outside. So reflection on x-axis. Okay, reflection on x-axis means what you have here. Same thing will come here also, right? And here left side. See here, whatever you have, here something you have like this, right? Its image on x-axis, you'll be having something like this, okay? So, in this case, this is y equal to x cube, right? Y equal to x cube, this is y equal to minus x cube. So, it's reflection on x-axis. So, this portion moves like this, and this portion moves like this, okay? So, now the next one is y equal to x cube and y equal to x cube plus 1. Y equal to x cube plus 1. So first y equal to x cube. So this is y equal to x cube. Y equal to x cube is the given curve. Now y equal to x cube plus 1. That is f of x plus 1. Outside you are adding 1. So 1 unit above. So the curve 0 is here, no? So 1 is here. Okay, the curve moves 1 unit above. Okay, so same shape, it moves 1 unit above. Then x cube minus 1, same curve, 1 unit moves below, right? So this is y equal to x cube. X cube minus 1, so 1 unit below, right? 1 unit below the curve, it moves. So x cube minus 1. This is y equal to x plus 1 the whole cube. Listen, y equal to x cube is the given curve, this curve. Y equal to x cube is there, right? X cube, but inside you are adding 1. Inside you are adding 1 means shifting to the right or left. So different. Okay, so here plus means move left side. Move 1 unit to the left. Instead of 0, you move here left side. Okay, so this is the second. This is the required curve, x plus 1. If it is x minus 1, move 1 unit to the right side. So curve will come here. Okay, then the graph will be like this. Okay, so that is for if it is what? Minus. If it is outside plus means it moves up. Outside minus means 1 unit below. Okay. So hope you understood that. Now see this one. Y equal to, see, y equal to x raised to 1 by 3. X raised to 1 by 3 means it is cube root of x. Don't confuse with both. The previous one is x cube, y equal to x cube. This is x raised, y equal to x raised to 1 by 3. So here they given the curve, but you prepare, okay, for the examination, even if it is not given, you must be able to do that, okay. Now what they asked first, minus of fx, right? X raised to 1 by 3 is the function, x raised to 1 by 3 is the function. Minus of x raised to 1 by 3 means this is it comes under the first one, okay? Reflection about x-axis, right? Minus outside. Minus inside means reflection about y-axis, okay? Power or raised to or f inverse. For inverse function only is a reflection on the line y equal to x. So here it is minus, so it's a reflection on x-axis, right? So whatever you have here, this will come here also. Then whatever you have this side, its image on x-axis, so it will come like this, okay? So, but the curve looks like this, it will come like this, okay? The inverse will minus of x raised to 1 by 3. So this is x raised to 1 by 3 minus x raised to 1 by 3 will be like this, okay? So it's image. Both if you draw together, you will be getting the curve like this. Hope you understood, okay? So that is the first one, x raised minus x raised to 1 by 3. Next one is x raised to 1 by 3 plus 1. X raised to 1 by 3 plus 1. So this is x raised to 1 by 3. Outside plus 1. So that curve moves 1 unit above. That's all. 1 unit above. So instead of 0, the corresponding point is what? 1. You have the curve 1 unit above. Minus 1 means 1 unit below. So the next one is minus 1, right? So same curve, 1 unit below. Next one you see x plus 1 raised to 1 by 3. Please listen here. X raised to 1 by 3 is fx. Now raised to 1 by 3 is there, but instead it is not x, it is x plus 1. Inside you are adding, so shifting right or left. Here plus 1 means 1 unit to the left side, right? So instead of 0, 1 unit to the left side. So minus 1, the curve will be here. Okay. Instead of plus 1, if it is minus 1, you have to draw here, 1 unit to the right. So see the next question. Graph the function fx equal to x cube. Graph the function fx equal to x cube. Y equal to x cube. Same graph only. And gx is cube root of x. Cube root of x means x raised to 1 by 3. Just now we saw both, right? Okay, graph the function of both. Both you got it. In the same coordinate plane. In the same plane you have to draw that. So both you draw in the same plane. I'll show how it is. Then find f composition G. We studied already, right? What is f composition? That actual calculation you have to draw. You have to do that and graph that answer also and explain your result. So first it's very simple question only. So x cube is the first curve. Cube root of x is the second curve. The previous questions and all, they given the hint, right? They given the diagram, but here nothing is given. You have to draw. So these are the two. Now both you draw in the same plane, you will be getting like this. See, something different, right? So we may not imagine how it will be, but when you draw together in a single graph, it will be like this, a beautiful diagram, right? And now they asked us to find what? F composition G. All of you know how to find F composition G. How in the previous class I taught that, right? F composite G means what? Of x you find out. So F composite G of x means f of G of x, right? So that is f of, what is G of x? Cube root of x. So put this value in f. What is f? X cube, x cube. Here what you write? Cube root of x the whole cube. Cube root of x the whole cube. So it is x, right? Cube root of x means x raised to 1 by 3. X raised to 1 by 3, the whole cube, 3 cancel, x raised to 1, or it is what x. So you are getting y equal to fx, y equal to x, right? So y equal to x means that's a line, okay? So you will be getting a line like this. So this curve is like what? Reflection, right? On the line. So that also we are drawing here. So the last part they asked, explain your result. So you have to say something about that. So this is the diagram. Both the curves we draw. Now f composition G. This is fx x cube. G of x cube root of x. F composition G of x. The answer is x. So y equal to x. That is the line. So now you see the line. Lines above and lines below. Both look same, right? So it is like a mirror image. Same thing here also, right? Here whatever you have, here also. So it is like a mirror, right? So it is a reflection. So these two curves are reflection on y equal to x, or you can say this is actually fx. Fx and gx are reflection on f composition G. Fx and gx are reflection on in the line, reflection in the line y equal to x or in f composition G. Now let's go for the next question. Write the steps to obtain the graph of this very big function, right? But here they didn't ask you to draw the graph. Anyway, we are going to draw the graph also. From the graph of, yes, even if it is not given, you have to start like that only. Why? So what do you need here? Y equal to 3 into x minus 1 square plus 5. Y equal to 3 into x minus 1 the whole square plus 5. The first step, what do you do? This is of the type x square. So first you draw the graph of x square. That is the first work. You know how the graph will be? Y equal to x square. The graph will be like this. Y equal to x square. Next step, you find this part. Instead of x square, x minus 1 square. Instead of x square, you find x minus 1. You are adding or subtracting something inside. So shifting right or left. Depends on here minus 1. Opposite you should think, right? Inside minus 1 means shift 1 unit to the right. Shift 1 unit to the right. So the curve will come here now. Shift 1 unit to the right. So the same curve, it moves like this. So this is x minus 1 square. Now 3 into, stage by stage you do. First x square, then x minus 1 square, then multiply by 3, dilation. When you multiply by 3 means more than 1, so the gap should increase, right? So it shrinks, it moving away from x-axis, so the graph will be like this. Okay, this is 3 into x minus 1 square. Then finally you have to add 5. Adding 5 means this graph will move 5 units above. Say this is 0. Suppose if this is 5, this graph will move 5 units above. Okay, so like this you do step by step. So first they asked you to write the steps. So I have written here what are the steps you have to do. The first step you have to start from y equal to x square. So from the graph of y equal to x. So y equal to x square you know. So next step, what's the next step? X minus 1 square. X minus 1 square. So what is happening here? Shifting 1 unit to the right. Then multiply by 2. Multiply by 2 means it is dilation. So if you want you can mention that also, the property, what we are using, what transformation takes place. The previous one is what? Shifting, translation. Okay. So here dilation, multiplying by 2. So it's moving away from x-axis. So we are multiplying by a number which is more than 1. So the gap will increase. That you think for the examination you don't do right like that. The gap is increasing, then your mark will decrease. Okay, so don't do that. So moving away from x-axis or moving towards y-axis, like that you can write. Okay. Then you are adding 5. So outside you are adding 5. So it moves 5 units upward. Okay, so these are the steps. And diagram, please listen. I'll just explain a little fast. Y equal to x square is this one. So your familiar one. So y equal to x square is the first step. Then x minus 1 the whole square. X minus 1. So shift 1 unit to the right. So the curve should come here, right? Yes, this one. Shift to the 1. Then you multiply by 3. More than 1. So this gap should increase. Okay. So it moves. So this one. This is the curve. Then adding 5. So this black color one graph I have drawn. No? So it moves 5 units above. So 5 units above. So this is the graph of 3 into x minus 1 square. Now above 5. So 5 is here. Okay. So 5 units above. So plus 5. 3x square. 3 into x minus 1 square plus 5. Look, another question. From the graph of y equal to sine x. So you start from the basic graph only, y equal to sine x. So look here I have drawn already, y equal to sine x. Sine 0 is 0, sine 90 is 1, sine 180 pi, so it goes like this. Okay, so this is sine curve. So first they asked to find y equal to sine minus x, f of minus x, right? F of minus x, minus outside, sorry, minus inside. Minus outside means reflection about x-axis. Minus inside means reflection about y-axis. So what will happen, you know? So whatever you have here, it is something you have here, no? So it will come like this. So it goes like this. So see, that is the curve for sine what? Minus x. Sine minus x. Okay, the sine x is the given curve. Sine x is the given curve, that blue one, that is sine x. Sine minus x means it is reflection on y-axis. Okay. But you know, sine minus x is same as, in trigonometry we study everything in detail, sine minus x is same as minus sine x. So adding minus and outside minus both are same. So reflection on x-axis or reflection on y-axis both are same here. Okay. So something you have to remember. Then minus sine minus x. Sine minus x you know now. Sine minus x is this red one. Outside a minus, so reflection. For that curve, you take reflection on x-axis. Okay, what happens, you know, if you simplify, sine minus x is what? Sine minus x is minus sine x. So that minus and outside minus, it become what? Sine x. So you will get the original sine x curve only. Minus sine minus x. See the blue one, that is exactly same as what? Sine curve, sine x only. Then sine pi by 2 plus x. So this is actually sine x plus pi by 2. So sin x, you know, you are adding pi by 2 inside. If you add pi by 2 inside, you have to shift pi by 2 units to the right or left. Inside, so it should be right or left only. Plus pi by 2, move left side, right? Pi by 2 unit to the left side. Actually, this blue one, that is the given curve, y equals sin x. Pi by 2 units, you shift to the left, so the 0 moves to here. Okay, so moving to the same concept only. It is sine curve, that's all. So this one, y equal to sine pi by 2 minus x, but I'll give a hint for that. Sine 90 minus x you studied from 9th standard, okay? Sine 90 minus x is what? Cos x. So definitely you are going to get the curve of what? Cos x only, right? Cos x means sine 0 is what? 1. Sine 90 is 0. Sine 180 is minus 1. Here the final curve will come like this. But I given the steps here. So here you take a minus sign outside. So x minus pi by 2. Sine minus theta is minus sine theta. So you can start with sine x. So sine curve you know. Sine curve you know. Then you find sine of x minus pi by 2. So after the previous one x plus pi by 2, no? X plus pi by 2. Instead of x plus pi by 2, now we find x minus pi by 2. X plus pi by 2, what we did? Pi by 2 units left. Shift pi by 2 units left. Here pi by 2 units to the right side. Then you find minus of x minus pi by 2. Minus of, that is fx is there, minus fx. So reflection on. For that curve, you take the reflection on x-axis and you will get that. So that I'm leaving it to you. You can complete it. Look at this one. It's a very simple one. From the curve y equal to x. Just I'm going to give you some hint only. From the curve y equal to x. You know what is the curve y equal to x? This is the line y equal to x. First they asked to find y equal to minus x. Minus x means outside minus. So reflection on what? X-axis. So this portion will move like this. So here it's reflection on what? Reflection minus of fx, right? So reflection on y-axis. Reflection on x-axis or reflection on y-axis, you can take anything because the curve is x, y equal to x. So outside you put minus, minus x. Replace x by minus x, both are same only, right? So reflection on x-axis or reflection on y-axis, you will get the same thing. So this is the line you will get. This is y equal to minus x, okay? This is y equal to minus x, answer for the first part. Second one is y equal to 2x. Listen, this is y equal to x. Y equal to 2x means you multiply by 2. So dilation. So more than 1, right? 2 into x. So more than 1 you are multiplying. So the gap has to increase. So it is moving away from x-axis. So the curve will be somewhere here. Okay. So this gap will increase. Okay. So that is y equal to 2x. Next one you see. Y equal to x plus 1. Y equal to x is this curve. Y equal to x plus 1 means just you move 1 unit above. 1 unit above. The same line will come like this. Okay. So this is y equal to x plus 1. For the next one you see y equal to half x plus 1. You can't do it directly. First y equal to half x. Half x means y equal to x you know. Y equal to half x. You multiply by half. Dilation. Less than 1, right? Half is less than 1. So the gap has to decrease. So it has to come something like this. This is y equal to half x. Then plus 1. So this line, that blue one, okay, that you move 1 unit above. So you will be getting something like this. Okay. So hope you understood that. See the last one. 2x plus y plus 3. 2x plus y plus 3 equal to 0. We have to draw the graph of this using y equal to x. Okay, so you find y from here. Y equal to minus 2x minus 3. Can you say how to do that? You find, first you find y equal to minus x. You find y equal to minus x. Y equal to x you know. Y equal to x is this curve, right? Say this is y equal to x. First I want y equal to minus x, so it will be in the other side, right? Y equal to minus x. This is y equal to minus x. Next what you do? The same diagram just I will explain. Y equal to minus x. So now multiply by 2. Y equal to minus x you have. You multiply by 2. 2 is a bigger number, right? So this gap has to increase. So it moves further like this. So this is y equal to minus 2x. So what's the next one? This curve is y equal to minus 2x. So what's the next one? Minus 3. Minus 3 means 3 units below. So this is 0, minus 1, minus 2, minus 3. So the line will come like this. So this is the curve y equal to minus 2x minus 3. So hope you understood. Like that, stage by stage you can do. So it's easily you can do this one. Okay, now just another one or two questions just to explain to you. Look at this one. So here, from the curve y equal to modulus x, it's a very simple one, right? Y equal to modulus x, draw modulus x minus 1 plus 1. You know what is modulus x? So just to explain to you, you can complete it later. So y equal to modulus x. So you know the modulus x, the curve will be like this, right? This is modulus x. So using scale you can draw. So this is modulus x, y equal to modulus x. Now first we want modulus x minus 1. Modulus x minus 1 inside. Modulus x is here. Now modulus x minus 1 inside you are subtracting 1. So right or left, right? So here minus 1. So shift 1 unit to the right. Shift 1 unit to the right. So here. So this curve is modulus x minus 1. Now modulus x minus 1, you got it. Now modulus x minus 1 plus 1. So it moves 1 unit above, right? Moves 1 unit above. Say this is 1. So this has to start from here. Okay, so this is that curve. So this is modulus x minus 1 plus 1. Now look at the next one. Modulus x plus 1 minus 1. Just I'm going to tell you how to start. You start with modulus x, right? You know modulus x curve. Then modulus x plus 1. What do? Shift 1 unit to the left. So first modulus x will be like this. Modulus x is like this. Shift 1 unit to the left. So say 1 unit to the left means say this is minus 1. So you will be getting like this. Next step is what? Modulus x plus 1 minus 1. So 1 unit down, right? So 1 unit down. So this will be your final curve. Okay, this is your answer. So look at this one. Again you start with modulus x. You know the curve. Then modulus x plus 2, what do? 2 units to the left side. 2 units to the left side. Then modulus x plus 2 minus 3. 3 units down, right? 3 units down. So first modulus x. So this is a curve y equal to modulus x. Next modulus x plus 2. Inside you are adding 2 means move 2 units to the left. Say it is minus 2. The curve will be here. Then finally minus 3. 3 units down, right? 1, 2, 3, something like this. So you have to draw the curve here. Okay. So that is the answer for this one. Now just I'm going to explain the last question. Listen here. From the curve y equal to sin x. So this is the curve y equal to sin x. Draw sine modulus x. Be very careful. What is modulus x? You know, modulus x means it is either plus x or minus x. It is plus x or minus x. So listen very carefully this one. It is plus x or modulus x or minus x. Modulus x is plus x if x greater than or equal to 0. It is minus x when x is less than 0. So sine modulus x means two values. When x is greater than or equal to 0, when x is greater than or equal to 0, modulus x is what? Plus x, right? Modulus x is x. So sine modulus x is sin x. Sine modulus x is what? Sin x when x is greater than or equal to 0. So when x is greater than or equal to 0 means this portion. So this portion, whatever we have drawn, it is true for even for sine modulus x also. But the left side. When x is less than 0, when x is less than 0, what is modulus x? Minus x. So sine modulus x means it is sine minus x. Instead of modulus x, you write minus x. Sine minus x is minus sin x. So it won't be sin x. Left side, it won't be like this. It is minus of sin x. Minus of sin x means what? It is a reflection on x-axis. Sin x is fx. Minus of sin x means reflection on x-axis. That is the left side when x is less than 0. Right side same thing only you are going to get. Sin x and sine modulus x both are same to the right of 0. That is when x is greater than or equal to 0. Sin x and sine modulus x are same. Please listen, it's a very important thing. But when x is less than 0, that is towards the left side, sine modulus x is same as, it is not same as sin x, it is minus sin x. Minus sin x means this is the curve for sin x. Minus sin x means it is a reflection on x-axis. So what you have here its reflection on x-axis. So that means like that you will be getting above. Okay. So here whatever you have, you will be getting here also. Okay. So you won't get this curve, you will be getting the other one. Okay. So hope you understood. So right side no change, but left side there is change. So in the right side no change, you will get this. But left side you won't get this. You won't get this. Instead of that, you will be getting what? You will be getting, you won't get this portion. Okay, you will be getting only this one. So this is the curve for what? Y equal to sine modulus x. Y equal to sine modulus x. Right side as usual, sine curve only, but left side minus of sine x. Okay, so because modulus x has two values, plus x or minus x, depends on when x is greater than or equal to 0 or when x less than 0. So in the right side means, so sine modulus x. In the right side, instead of modulus x, you put x itself. So that is why right side no change, same sine curve. But in the left side, sine modulus x is minus x, right? So sine minus x is minus sine x. So you can't take sine x curve minus of sine x. That is minus fx, reflection on x-axis. Okay. So don't take this one, what I marked here, no? So that you don't take. Instead of that, you take the reflection that I drawn using this red color. Okay, that one you have to take. So you get this. So hope you understood all these things. Very simple topic. 3 transformations we study, right? First one is reflection, second one is translation, and the third one is dilation. With this idea, I'm sure you can answer any question. We'll continue the next class.